Everybody, this is page 411, and we are continuing our conversation on what properties of trapezoids with one pair of parallel sides gives us. Let's analyze the worked example that we have from page 410 with TRAP and Z as the line, the point on the middle of TR that creates a parallelogram and an isosceles triangle. And let's get into it. They're asking us in this question, what is the significance of constructing ZP parallel to RA do in leading towards a conclusion? And honestly, let me go ahead and pop over to the question for a second. So pause here and then write, but go ahead and look at what I'm looking at over here. By creating Z so that this line is parallel, this parallelogram sets up the fact that the sides are congruent, and that means this side and this side are congruent. So you create an isosceles triangle, and in an isosceles triangle, base angles are congruent. Statement 8 says that we have to use the corresponding angles theorem. We're saying that angle TZP, so I'll try to put everything up on the screen here, angle TZP and angle R are congruent. And you know, we're using the fact that a parallelogram has parallel sides. And when you have parallel sides cut by a transversal, then you are identifying corresponding angles that are congruent. So we're going to link together angle T to TZP, TZP to angle R, and along the way that tells us that we have all three angles are actually equal. They are the base angles. All right, here's the deal. You have to also show that angle A, so that's this angle, and angle TPA are congruent. Now let's do it. Now here's the thing is, since TR is parallel to PA, and TP and RA are technically transversals of TRPA, we're creating same side interior angles. So like angle R and angle A are same side interior angles. Angle T and angle P, all of angle P, are same side interior angles. Since R and T are equal, then angles equal to supplementary angles already must therefore be congruent. So we're going to say it all like this. Same side interior angles and congruent supplement theorem tell us that angle A and angle P are congruent. There you have it. Kala insists that if a trapezoid with one pair of parallel sides has only one pair of congruent base angles, then the trapezoid must be isosceles. And she thinks that proving two pairs of base angles are congruent is not necessary. Is Kala correct? Yeah, of course she is, because the same side interior angles theorem, using parallel sides and already congruent angles in two different spots, tell us that the other pair of angles must be congruent. So we know the trapezoid is an isosceles, and all of the base angles, like the two bottom ones and their matching top ones, must be congruent to each other and to each other with, well, really with this, the same side interior angles theorem. Oh, and also this one, the congruent supplements theorem. Like it's like you don't need to prove it anymore. You get it with part of the work that you did. That's the 411, right? Page 411. There's a phone number you could call. Call the 411 for more information. Thank you for watching this video and getting the information from properties of trapezoids with one pair of parallel sides. I'll see you in the next video. More to follow. Thank you for being here on your geometry journey. See you in the next one video.